My friends, with great power comes great responsibility. And that was true in August 1962, and it's true today, especially with this command I'm about to show you, and not show interface trunk. You can run that you can run that one anytime you like. But you'll notice a big difference here in the output of show interface trunk than we saw in previous videos. Because now on port 6, my VLANs allowed on trunk are only 5, 10, and 20. You'll also notice VLANs allowed and active in the management domain, none on port 6. That might not be good. And VLANs in spanning tree forwarding state and not prune, none. We're really concentrating on this one right now though, 5, 10, and 20. Now I will show you how I did that, but before we look at these options of this rather verbose command, I want to show you a scenario where filtering VLANs might come in handy and where it might not, because you've really got to see the big picture of your switch network when you start filtering VLANs. You can't really just look at the downstream switch and say, okay, that guy doesn't need it, so we'll just filter VLANs here. Let me show you exactly what I'm talking about. In this admittedly small switch network, filtering VLANs could be a good idea, because you've got one switch with hosts and VLANs 20 and 30. It's trunking with another switch that only has hosts and VLAN 20, and then it's also trunking with a switch that only has hosts and VLAN 30. So there's no reason to send this switch with hosts and VLAN 30 frames destined for VLAN 20, right? Because it's just unnecessary overhead. It's not going to use them for anything. It doesn't have anybody to forward them to. You also might want to filter frames for VLAN 30 that are currently being sent to the switch with only hosts in VLAN 20. Because again, you're saving a little bandwidth, you're saving a little overall workload, right? So that would be a good plan if this was your network. What you have to be wary of, and why I mentioned responsibility earlier, is a situation like this. You have 3 switches with hosts in VLANs 20 and 30. And none of those 3 switches are trunking with each other. They're trunking with switches that only have hosts in VLAN 20 and 30. But let's look at this top path. The only way for the hosts in VLAN 30 to get anything, to get their frames, is for it to go through this switch. So if you filter VLAN 30 out here on this top switch, these guys in VLAN 30 down here can't possibly get their frames. They're not even going to be sent to this switch. So that's the kind of thing you got to watch. So let's go ahead and take a look at the command, and we'll look at the options. Like I said, quite a few here. This is an interface level command, and it is switch port trunk. And we've got allowed, native, and pruning here. Pruning we're saving for future studies. Native, that's with changing the native VLAN. We're going to look at allowed. That's what we want to focus on. And then you put VLAN, and then here are your options. You just have to be careful that you're using the right one to get the result you want, because we do have quite a few options. You can list the VLANs individually with just putting them numerically and just putting a comma between them. If you need to add VLANs to the current list, you can do that with the add option. If you want to add all VLANs to the trunk, just use the word all. That's a really good quick fix if you're working with filtering and then all of a sudden you realize somebody downstream isn't getting the frames they need to get. And while instead of taking a lot of time to figure it out, you can just do an all and then go back to your list and say, okay, what did we do wrong here? What do we need to change? Except, just be careful with that one, because that's all VLANs except the following. So if you just need to exclude one, there's no reason to type 4093 numbers. You wouldn't do that anyway, but there's no reason to type that many numbers. You can just use except. If for some reason you want to stop all VLAN traffic from going across that trunk, you can use the word none. And you can see remove VLANs from the current list. So if you needed to edit it again, the words add and remove do come in handy. So let's say right now that we needed to add VLANs 45. We would use the word add here and then just 45, and that's it. That's all there is to it. So let's do a show interface trunk, and you can see now that 45 was indeed added to the list. So again, a good example, let's use the all example. Let's use that real quick. Thank goodness for the up arrow. There we go. Let's go back in the allowed VLAN command. And let's put all. And you can see you're right back where you were. So you just have to be careful. The command is not difficult at all. It's just a little long. Switch port trunk allowed VLAN, and then you follow it with the option that you need to use. Again, what you want to do is be careful with where you're filtering those VLANs, because it can lead to a little bit of trouble, as we discussed here. Now, another natural question that leads us to the next video, the next topic, is if these switches in the middle don't have hosts in all the VLANs, then how does it know about those VLANs, and how can it serve as an intermediate? Let's put it this way. This switch has no hosts in VLAN 30. So when you run show VLAN brief, it's not going to show VLAN 30 by default. So when it gets a frame from one of these two switches for VLAN 30, if it doesn't even have an entry for it, it's not going to send it out its own trunk. It's just going to say, hey, I don't even know that VLAN 30 exists. I'm getting rid of this. The way we do that is with a very important and non-complex protocol compared to OSPF anyway. It's a layer 2 protocol called the VLAN Trunking Protocol, VTP. And we're going to look at that, the 3 modes that it runs in, and some important defaults in the very next video. I'll see you there.